Alright, let's do an example. So here, again, that's an initial value problem, which means we have a differential equation and an initial condition. So let's begin with the differential equation first. So it is a linear differential equation, so we can move 2y to the left-hand side to see that. So y prime minus 2y equals minus t. Right, so this coefficient at y, which is -2, is our p of t. So the first step is to find the integrating factor, and the integrating factor is the following thing. So we should raise e to the power integral of the p of t, so minus 2 dt. The integral of minus 2 is minus 2t, so we get e to the minus 2t. So notice that I didn't write plus constant because, again, I don't have to find all possible integrating factors. Okay, so then, since it's a factor, it means that I need to multiply my whole thing by e to the minus 2t. Right, so my whole thing is e to the minus 2t minus, I'm sorry, I forgot y prime, minus 2 e to the minus 2t y equals minus t e to the minus 2t. And then, as the method suggests, this should be the derivative of the product e to the minus 2t times y prime. So is it true? Well, I think you can easily check that if we differentiate e to the minus 2t times y, then we are going to get e to the minus 2t times y prime, which is this, plus the derivative of e to the minus 2t, which is minus 2 e to the minus 2t times y, correct. So this is true. So it was just a little verification. So indeed we didn't make a mistake. But then it means that e to the minus 2t y equals antiderivative of minus t e to the minus 2t dt. Alright, of course, I could solve this integral by integrating by parts, but it's a bit troublesome and it's very easy to make a mistake, so I'll just do it in Wolfram Alpha. I hope you'll forgive me for this. So I need to integrate minus t times integrate minus t times exponential function of minus 2t dt. Alright, so 1/4 times e to the minus 2t times 2t plus 1. Okay. So this is 1/4 times e to the minus 2t times 2t plus 1 plus constant. Correct? We check. Yeah, great. Well, then I need to solve for the constant. So let me continue. I will write that e to the minus 2t y equals 1/4 to the minus 2t times 2t plus 1 plus constant. Sorry. Now let me use the initial condition. Right? So according to the initial condition, t is 0 and y equals 1. Right, so I'm going to substitute this. E to the 0 is 1, y is 1, so the left hand side is 1 equals 1/4 times e to the minus 0 again is 1 times 0 times 1 plus c. So c is 1 minus 1/4, is 3/4. Okay, and also we need to multiply this whole thing by e to the 2t so that it would cancel out, so to solve for y. Alright, so then y equals 1/4, e to the minus 2t cancels out, times 2t plus 1 plus constant, which is 3/4, and then we get e to the 2t. Well, if you want, you can rewrite it as, I don't know, 2t plus 1 plus 3e to the 2t quarter. So that's going to be the final answer.